Hey everybody, this is Larry. This is me going for Q4 of the recent weekly contest 225 or 255. Wow, oh no, 225. Okay. Building box. Hit the like button, hit the subscribe button, join me in Discord. It's been a little bit of a rough time for me lately, so definitely if I don't have the energy, excuse me, and let me know what you think about today's problem. So this one I actually thought was kind of hard, but maybe it's because I'm bad at these math counting things. But a lot of people solve this, and I think there are a couple of formulas that you can do. I'm going to explain my way. I think my way makes sense, but I do not recommend my code. My code is ugly as hell. I definitely do not recommend it. I recommend you try to understand my logic and then implement it in your own words, hopefully in a better way. Yeah. So basically, for this problem, the idea that I had was, actually, I think I should have just added a thing, and then that would have made it a little bit straightforward. Let me see real quick. Yeah, okay. But yeah. So basically, that's not even true. That is. Okay. So basically, this is my code. There's a lot of debugging. Let me clear that out. But yeah, so basically the idea is that, I pre-calculate this array, and this is the triangular array. This is the base where you can build from. So it goes from 0, 1, and then is it? Let's see. Yeah, 1, 3, 6, 10, 15, 21, and so forth, right? So that's basically the progression of the last block, right? So that's basically my the base that I work off. I think this part should be straightforward. There are other ways to write this for sure, but and I ate a wrong answer because I don't know, my infinity was too low. But yeah, this is just pre-calculating this part, and you can kind of draw it out yourself to kind of prove to yourself. Basically, you start with 1, and then next you have this, and then and then you add 3, and then the next one you add 4, and so forth, right? So yeah, so that's how I come up with this, and then that's how you get the number of blocks in the last block, right? And then after that, next thing that I want to go over, and I'm skipping ahead a little bit because is that I have a binary search for the answer. I like binary search problems in general, so definitely pay attention a little bit because I know that some people maybe I go over too quickly. But basically, the first thing that I say is, okay, this is inclusive. So we want left and right to be both within the range, and when we get one number in the range, if left is equal to right, so that's just why we have a while loop like this. We set the middle, and this is just regular getting middle, and go just counts the number of total blocks that it could support. So basically, what is go, right? Let me rename this. And I cached this, so I don't know if this is necessary, to be honest. I think actually count. Let's call it count box. So what is this function? Let's say we have a black box for now. We'll go over in a second. Count box gives you the total number of boxes given the last level is mid, right? And what this means is that if the bottom level is mid, we get count box number of blocks, and if this is greater than or equal to n, that means that we can try smaller numbers, right? And because this is equal to, we could set right is equal to mid, because this is the inclusive range. So this is why this is why right is equal to mid, because mid is a good value that we want to keep. Otherwise, that left cannot be. Mid is not good, so you want to try more blocks on the bottom, and then you move left to mid plus 1, because we already know that mid is no good, so we do a plus 1 there. And here, as I said, it gives you the number of total boxes. So once you have this magical box, we're able to do this. I actually have trouble with this one, though, apparently. I wrote it this way, though, to be honest, this is just a for loop as well. But basically, I wrote it yeah, in a really funky way. But I just want you to know kind of how I came to it, and you could write it in a better way. And you can leave in the comments how you wrote it, because a lot of people wrote this in a better way. But basically, my idea is that, okay, so you have this array, right? Okay, so if the bottom is 15, then you're done, right? Because you have 15, then we just want to go, we look at the bottom, and then we recursively, oh, this is count box. Oh yeah, then this is done, because if we do a binary search to get this index quicker, that's just, to get it a little bit quicker. But yeah, if this is equal to this, that means that this is done, because 15, then the box above, or the level above has 10 boxes, plus 6, plus 3, plus 1, and so forth. This is going to take square root n of time, so this is going to be pretty fast in general. And this takes, I don't know, given, was it I did 100 million, so that's going to be like 20 copies, 30 times square root of n, where n is a billion, is going to be fast enough, because it's just 20, 20 or 30 times 10 to the 5th is fast enough, just like a couple of million. And it's actually less than that, but that's just me hand waving math right now to kind of prove to you why, on top of my head, that's how I was able to do it. But yeah, so this is the perfect case where this is equal. But what if it's not? Well, if it is not, then what's on the bottom layer, right? Well, on the bottom layer, well, we have bottom because that's defined. But how do we figure out how many on the layer before that? So the way that I did it is having this funky equation. But the idea behind that is that, okay, so let's say we have this, but instead of an X on top, we have an X, a circle on the bottom. So instead of having 10 blocks, we have 9, right? Well, what does this mean? Actually, well, the other way the reverse way of thinking about it is, okay, let's say we have 6, right? And we're getting to 10. Well, what happens? Well, if we get 1, the first number we do, it adds no extra boxes to the previous level, right? And then now the second one does, because now this block on the previous level has a block. So this one adds this block on the previous level, which, there's a recursive nature of this as well. And then lastly, adding this block adds this block as well, which allows you to do this recursively. And that's basically my idea. So K is the block that's before. So yeah, so let's say your bottom is equal to 8. This thing is gonna go to, your current number is 6. So then the one before that is gonna be 3, and then the extra is equal to 2, and given 8. Sorry, is this 8? That's messed up. This is actually 9, so I think maybe I misspoke earlier. But yeah, so this is 8. So yeah, so there are 2 extra blocks that are from the 6, and because you have 2 extra blocks, as I said, you have 1 extra block on the level before. So that's basically just how I did this math, where I take the index of the DP over 2, which is the level that's 2. So this is the biggest level. The biggest previous level. We count the number of extra here, and then we add it to recursively. We look at 2 levels ahead, we look at the levels ahead, and then we add in those extra blocks, because those are the extra ones that we get to add in. And that's basically what this function does. And yeah, again, I really think I looked at some solution doing code review. They're way cleaner code than this, but that's kind of my logic. And as long as you have that logic, you can definitely rewrite this in for loops. It's just that for me, during the contest, it was easier to think about it this way. You may think about it in a different way, or you may try to understand it in a different way. But those are the invariants that I saw when I solved this problem, and that's how I figured this out. And also, I just kind of have this, if it's less than 0 or less than 2, then we just return that number of blocks. Yeah. Whew. Yeah, that's all I have. Let me know what you think. You can watch me solve it during the contest. next, but let me go over the complexity. I forgot. So in terms of space, this is square root of n, which is technically exponential in the number of bits. In terms of space, I don't use space otherwise, so that's the only time I use space, except for if you want to count the stack space. But that's going to be also square root of. No, this is log. No, this is also the square root of n, so yeah, so also exponential in that sense. So I guess this also takes on a stack space, this will call square root of n times. So yeah, in terms of complexity, I have a log n here, and on this, to be honest, now that I think about it, you could have passed this down, so you don't need to do a binary search every time. You could have, for example, this is just this, and then you could have like maybe this will get an index function, and then and then you have like an index -1 or something like that. I'm going to change the code back because I don't know if that runs, but that's basically the idea, to reduce that space, reduce the time. But during the contest, I didn't think it mattered, and it didn't. But these are things that I would do if I had more time. But yeah, and then, but yeah, after that, so this, as I said, this would call itself a square root of n times for each mid function. So you have, and this is a log of the universe loop, which takes about 20 to 30, depending on how you do it. But it depends on the infinity that we set, or the max number, depending on how you want to set it. And yeah, so that's square root of n times log n, something like that, roughly. So that's the time complexity, and the space again is just square root of n, with some optimizations perhaps around this so that we don't binary search in every time, because once we do the binary search on the first one, we can go down pretty much straight up. And you don't even need to do a binary search if you're only doing it once. You just do a for loop going up and then for loop going down. This is actually kind of now sad that I wrote it this way, but during a contest you do what you can, and I did grind it out, even though I took a long time on this one. But yeah, that's all I have for this problem. I'm going to leave this code here. Let me know what you think, and you can watch me solve it live during the contest next. Bye bye. I can't believe I solved that one in like 2 minutes. What a waste. Okay, let's see, put in boxes. If X and you took the 4 vertical size must be adjacent to another box or what? Boxes are placed in the corner of one vertical. This seems straightforward, maybe, but I don't know, because there are a lot of smart people and they should get it before I do. Would be roughly square root. It's like 1, 3, 6. Right? And then another 4. So the base is 1, 3, 6, and 10. And then the sum of those, right? So this is going to be roughly square root. 5. Really? Let's print db just in case. Yeah, okay. That's probably right. And then, okay, let's try the 10 to the 9 case. Oh. 42,000, that's not bad. Okay. So those are the possible answers. So how many bases are there? So for the this goes to 1, and then it is 4, and then 10. This feels right. So then now it is just binary search on this. Maybe not even. So 10. So then now let's just return. Can be this easy though, right? Or am I just confused? Let's try. Oof. Okay. Oh, I see. Because if you have 15, let's see. Okay, because if you have 15, it up to 20, but you don't actually need to use all 10. Okay. Let's see. We could do a binary search of some sort. So this is harder, obviously, than I thought. A lot of people got it, but so what happens if we have 9, right? We reduce this to 9, then it is 9 minus 3 more, so if this is 9, how much can it support? 16. I want this to be inclusive. Also, I want to make sure that this works for 1. Okay. And the last one has what are we doing? So there should be 6 and 10. Okay, that's good. I actually don't know about this, so I have to be careful. So we want this to have we want this to have 4. Because that's the level that we're adding. Okay. So if this is we can go smaller. Oh, really? Just not my day. Let's see. $126 should have been 36. I agree with that. Did I get the signs wrong? So this is the number If this is too big, we can make it smaller. If this is too small, we make it bigger. 45, hey? Why does it get bigger? Distort. So this is 72. Did I mess that up? 36 should give us more than 72. So my formula is wrong. How did I get it right before? Just luck? Okay. That's not good. Oh. $40, that's too big, that's too big. That is too small. 36 has 120. Is that wrong? Is that not enough? I was expect it's 39, not 36 anyway. Okay. So it's 36 plus. Oh, it's 120 plus 1, 2, 3, 4, 5, 6, 7, 8. Am I wrong? Why is it 36? Why is it 39? Maybe I am wrong. Okay, so if I take one here, I have to take all this. But then I take one here. Oh, the second tick is only off by 1. Wow. Okay, this is harder than I thought. How do I do it? It's basically just 1, 2. some recursive thing that I think the binary search is right. It's just it's recursion to kind of calculate that. I'm just not really smart right now. I should have skipped this one. I'm not in good mental state to do it. Is that even optimal? And in fact, you don't even want to remove this in order, because what you actually want to do is remove them like this, so that you have 2 and 2. So for 8, seven I guess has to be this, and 6. 7, but 8 is the key one that lets you do 3 by 3. How do I even know this? I thought it would be something like this, but let me see. I mean, it's going to be binary search, and then you have this function that lets you do it, and then you recursively go down. I just don't know how to do it. 5 by 5. Can you generate a 4 by 4 here? It's not even 4 by 4. It is, you know, this idea that you can have is this idea that feel like I'm better at doing this one, but I don't have any test cases to work on either. This is just the worst thing of my thingy. Can we do in a for loop? Or there's just a couple of forms. I think that's the tricky one that I'm trying to figure it out. Is at 8. If you have 8, then you want to do this so that you can support. Oh, is that true? No, because this doesn't have to. No, so that you can support. No, I think I made that up. It's still the same. Because you only need to care about, even if this is the case, you cannot make a 3x3 thing anyway. No, but you can. And if I have it here instead, then I can have these 3. This one, which is the same as if I have it here. Okay, so I was wrong. So then this is 2x2. So greedily do this. Then how do we do it? Okay. Yeah, I resubmitted it, so whatever. That should be good enough. How many boxes does this support? Right. So if this is 8, this is 4. So it goes up to n squared over 2, something like that. So if this is, what number did we say it was? I printed it out. Let's see, it was 1, 3, 6, 10, I think, 15. So that's n choose 2, so that means that how many things can it support? If this is 15, which is times 2 is 30. I don't know if this is too slow, but let's give it a go. Okay. Maybe I shouldn't have deleted it. Actually, I could just go for this. Nope. I don't know, it doesn't really matter. So basically, if the bottom layer has, you know, bottom, so this is TP. This might have gone the wrong way, but that's fine. What am I printing? Oh yeah, this is the bottom. So then now we take K, which is the most, right? And then bottom minus K. So then this is the duck is like. Oops. Oh, that's not good. What's the answer? Well, that's not great either. So let's say the bottom is 6. What's my answer here? get 8, that's not right, is it? No, because if you have 6, hmm. 6, 2. No, that shouldn't be right. Right? Okay. I wish I kept my answers for it, but I think the one that I remember is 126. 15 and 126. Okay, I printed way too much, but it's still wrong though, unfortunately. 15 is right, 37 is wrong. 129, why? I wish I'm on a real coding thing. Okay. So 37, the next one is 29, is that true? Oh, so just for fun, that's 37, 29. Is that true? $36. So what's 37? 37 is, so then minus 4. 8. So minus 8. Minus 7. I don't know this one. Maybe I'm just so bad. Just off by a little bit the entire day, it seems. Well, 2 to 1 is not true, right? So that's definitely that. What's 4? 4 is 1, 2, 3, 4, which is at most 1. So this is actually also wrong. 4 is 1. What is the array? The array is so for 4 it goes 6. My math is off, but I have 20 minutes to fix it. 1, 2. Is this -1, I think. But I think I'm a little bit off on that. Yeah, this is too much. Oh my. Maybe I'm just thinking about this the wrong way again. Well, 3 going to 0 is definitely wrong. Is this -1? So it's 4. Okay, so if it's 6. So for every 2 above the previous one. Okay, let's do that. This is the next one. And then now so then now you have extra is equal to okay, for every extra I don't know why I put it there. Well, that's just clearly not right, but I think I'm off by 1 here. Yeah, I went over, but $122 still too low. Missing by a couple of blocks. So we have 5. What's 5? 5. You have 2. That's right. You have 9. What's 9? 3, 4, 5, 6, 7, 8, 9. So 9. You have actually 1, 2, 3, 4, 5, 6. This is roughly right though. This is not right, but we'll see if it's actually right. Nope. Is 10 7? No, 10 is 6, so I'm wrong on that one anyway. But I may be just off by 1. Ooh, oh, this is easier to fix. I should have tested this case. I thought about doing it. Okay, let's see. I just didn't think about it too much. Where's the answer from? Okay, let's try. Okay. Hey everybody, thanks for watching. Thanks for checking out this problem. Let me know what you think. Let me know what you're running into, and I will see you hopefully next time. Bye-bye.